Hey guys, so today we're going to be talking about permutations and combinations. So a permutation, what I like to think about is that, oops, it's sounds more complicated, and it is, which is why order matters. A combination, order does not matter. So you can also think about it like this: if you think about a combination lock with those three numbers, right? It actually should not be called a combination lock. It should be called a permutation lock, right? So let's say the code is 123. You can't just put in 3, 2, 1, right? It won't unlock. Even though they're the same numbers, it won't unlock because the order that you put them in it matters. So it's called a combination lock, but to be absolutely correct, it should be called a permutation lock. That's kind of how I used to remember it. And so let's get to some questions and kind of put these into action. So a horse race has 12 horses. How many ways can first, second, and third occur? All right, so the first thing I see is that they're asking about the order, right? So we can break this down. First, second, third. So let's say name the horses Bob, Joe, Tim. Okay. So Bob, Joe, Tim. Bob won first place, Joe won second place, Tim won third place. This outcome is not the same as Joe winning first place, Bob winning second place, and Tim winning third place. Right? It's not the same. So the order that these horses win first, second, third, it does matter. So we can say that it's a permutation. And there's a permutation formula, and you'll learn that in the next video. But for permutations especially, I kind of just like to kind of show how to write each thing out, and it kind of makes my life easier. So it says a horse race has 12 different horses. How many ways can first, second, third occur? So there's three possible places. So first place, 12 different horses can win first place, right? 11 different horses can win second place, right? Because one of them already won first. And 10 different horses can win third place, right? Because the two already won first and second, right? So again, 12 different horses can win first place, 11 can win second place, and 10 can win third place. So you multiply them all out, and you should get 1320. So there's 1,320 ways for first and second to occur, and that is our answer. And this is our next question. So, in a group of 10 people, 3 prizes will be given out. How many ways can the prizes be distributed? Okay, so let's think about this a little bit hard. In a group of 10 people, 3 prizes will be given out. Again, let's say Bob, Joe, and Tim, right? They're all happy they won the race, so they're getting prizes. So, Bob, Joe, and Tim doesn't let's think about it. Does it really matter if Bob gets the prize first, or if Joe gets the prize first, or if Tim gets the prize first? Or does it matter if Joe gets the prize first, Bob gets the prize, and then Tim? It doesn't really matter, right? Because they're all getting the prize at the end of the day. They're all getting that same prize. So, what you do here, it's a combination, right? Because the order that you give out the prizes doesn't matter, right? Because they're all getting the same prize. So, combination, right? Order does not matter. So, in a group of 10 people, 10, and you're choosing 3 of them to get the prize. And this would end up being, using the formula, 10 factorial over 10 minus 3 factorial, 3 factorial. We can keep going. 10 factorial over 7 factorial, 7 factorial, 3 factorial. So 10 times 9 times 8 over 3 times 2 times 1, right? Because the 7 canceled out, the 7 factorial canceled out. So we get 3, 4, and we get, so now there's 120 ways that the prizes can be distributed. So it's kind of tough to kind of see, will the order matter, will the order not matter? So you just kind of have to draw it out, think about it a little bit, right? Because it's not like this, right? It's not first, second, and third. is they're just giving out prizes. Everyone's gonna get the same exact prize. It doesn't matter if Bob gets it first, or if Joe gets it first, or if Tim gets it first. It doesn't matter as long as each person gets the prize. So this is combination. All right. So Bob, Alice, Joe, and Sam are in line for a photo shoot. How many ways can they line up? Okay, so Bob, Alice, Joe, and Sam are in a photo shoot. All right, this is first thing we want to think about. Does the order matter? Well, let's draw it out. So Bob, Alice, Joe, and Sam. How many ways can they line up? Well, Bob, Alice, Joe, and Sam. Isn't this a different lineup, right? If Alice and Bob switch, right? So if it's Joe could be the first person, right? So I'm thinking that the order does matter, right? Because each person could swap and it'd be a different photo, right? So Alice could be in the middle, or Joe could be in the middle, or Sam could be in the middle. They're all different photos. So its order matters, which means it's a permutation. Permutation. All right. And again, I'm going to use those 4 lines, right? Because there's 4 people. So, how many people can be in the first seat? Well, Bob, Alice, Joe. So there's 4 of them, right? How many can be in the second? 3 of them, right? Because one of them is already in the first. How many can be in the third seat? 2. And then there's only 1 left, right? So it'd be 4 times 3 times 2, which is 24. So there's 24 ways for them to line up in a photo shoot because the order that they're standing or sitting matters, right? So if Bob is first, that's a different picture than if Alice is first. That's kind of how you think about it, how you can just draw this out. So, how many ways can you select 3 fruits out of a basket of 4 fruits? All right. So, 3 fruits out of a basket of 4 fruits. Again, does the order matter? Well, let's say we have an apple, orange, banana, and a pear. If I take out an apple, then I take out an orange, then I take out a banana, is that the same as me taking out a banana, then an apple, and an orange? Yes, it is. Right? Because I'm taking out the same 3 fruits. So, order does not matter, which means it's a combination. Right? And we can see order does not matter, right? Because if I take an apple out first, and then an orange, and then a banana, I'm still picking out the same 3 fruits as if I were taking out a banana, apple, and then an orange, right? So it doesn't matter what order I pick them out in. So now that it's a combination, we can use the formula, right? So there's 4 fruits, and I'm choosing 3 of them, right? So it's 4 factorial, 4 minus 3 factorial over 3 factorial, which is 4 factorial, 3 factorial, right? 1 factorial is just 1. So 4 factorial over 3 factorial is 4. So that means there are 4 ways for me to select 3 fruits out of a basket of 4 fruits. So I hope this helped. Thank you guys so much for watching. I know permutation and combination can be a little bit tricky, but we'll get into the permutation formula a little bit later on. But I hope this helps you guys. If you guys enjoyed this video, please consider subscribing and leaving this video a like, and I'll see you guys in the next one.